Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into quantum fields, a way of seeing the universe that is gentler, deeper, and perhaps more calming than the solid world we imagine during the day. But before you settle in and get cozy, I'd love if you could take a brief moment to like this video and subscribe, only if you truly enjoy these slow, thoughtful explorations. And when you're ready, feel free to leave a comment letting me know where in the world you're listening from and what time it is for you right now. It's always comforting to remember that this quiet moment is being shared across many places, many nights, all at once. Now, you might want to dim the lights a little, maybe turn on a fan or let a soft background sound fill the room. And if your mind begins to wander as we go along, that's perfectly fine. Let it drift. We'll be moving slowly, with no need to rush. Tonight is not about memorizing facts, but about gently reshaping how reality feels. For a long time, most of us have carried a simple picture of the universe. We imagine space as an empty stage, and on that stage sit countless tiny objects, particles, each one solid, distinct and separate. This picture is comforting. It feels sturdy, it feels familiar, and for everyday life, it works well enough. But as we'll discover together, this picture is not quite how nature tells its story. Beneath the surface of solid things lies something quieter and more continuous, something less like a box of beads and more like a calm ocean, stretching everywhere at once. Tonight, we'll begin to ease into that ocean, one slow idea at a time. And so, when you're ready, let's begin. For most of human history, the world has felt solid in a very literal way. You can tap on a table and feel its resistance. You can hold a cup and sense its weight. You can stack stones, build walls, and trust that those walls will stay where you put them. From these everyday experiences, a natural idea forms almost without effort. Everything around us must be made from tiny solid pieces packed closely together. It's an appealing picture. Imagine breaking matter down again and again. Wood into splinters, splinters into dust, dust into grains, grains into ever smaller bits, until at the very bottom you reach the smallest possible pieces, tiny beads of matter, indivisible and firm, floating in otherwise empty space. This idea has been with us since ancient times, and even today it quietly shapes how we think about reality. This beads in empty space picture feels reassuring because it mirrors how our senses work. Our eyes see edges, our hands feel surfaces, our brains are very good at tracking objects that move from one place to another. In daily life, the world behaves as if it truly is made of solid parts, each one clearly separated from the next. For a long time, science agreed, at least in spirit. Early atomic models described matter as built from particles much like tiny marbles. Even when electrons and nuclei were discovered, they were often drawn as dots and spheres, neatly arranged, orbiting one another like planets around a star. Textbooks filled with clean diagrams reinforced the idea that, deep down, reality was still made of little things. And there is a reason this picture lasted so long. It works astonishingly well at human scales. It lets engineers design bridges, chemists predict reactions, and doctors understand how materials interact with the body. In this sense, the solid particle model is not wrong. It is simply incomplete. The cracks in this comforting image only appear when we look very closely, or when we try to explain things that seem, at first, a little strange. Light, for example. Sometimes light behaves like a stream of particles, arriving in tiny packets of energy. Other times, it spreads out and interferes with itself like a wave on water. No matter how carefully scientists tried to force light into one category or the other, it refused to stay put. Electrons behaved just as stubbornly. When fired one by one toward a screen, they did not land as neat, isolated dots. Over time, they formed gentle wave-like patterns, as if each electron had somehow explored many paths at once. The idea of a tiny solid object travelling along a single, well-defined track began to feel less convincing. Atoms too resisted the old picture. If electrons were truly small particles orbiting a nucleus like planets, they should constantly lose energy and spiral inward. But atoms are stable, they persist. They hum along quietly, obeying rules that seem less like mechanical motion and more like carefully chosen possibilities. These observations did not shatter the old model all at once. Instead, they softened it. Little by little, physicists began to realize that the universe might not be built from solid pieces sitting in emptiness, but from something more subtle beneath it all. At this early point in our journey, it's important to notice something gentle and reassuring. Science did not abandon the particle picture because it was careless or eager for mystery. It let go of it slowly, reluctantly, guided by evidence and patience. The goal was never to make reality feel stranger, but to make it make sense. What began to emerge was a quieter foundation, one where the universe is not a collection of objects placed into space, but a continuous structure where space itself carries behaviour. In this view, what we call particles are not the starting point. They are outcomes. They are the visible moments when something deeper briefly shows itself. For now, it's enough to sit with this idea without trying to solve it. The solid world you know has not vanished. Tables still feel firm, floors still support your weight. But beneath that familiar solidity lies a calmer story, waiting to be told in slower terms. As this idea settles, like dust drifting gently downward, we can begin to loosen our grip on the image of tiny beads in empty space. Not because it was foolish, but because it was a first step. And beyond that step, a more peaceful picture is quietly coming into focus. When you're ready, we'll allow that picture to grow clearer, without forcing it and without rushing ahead. At first, the solid particle picture only seems to crack at the edges. Most of the time, the world still behaves exactly as we expect. Objects fall when dropped. Balls bounce. Light turns on instantly when we flip a switch. Nothing about daily life demands that we rethink reality from the ground up, but when scientists began to look more closely, much more closely, those edges started to blur. Light was the first to quietly rebel. For centuries it had been described as a wave, spreading smoothly through space, bending around corners, interfering with itself like ripples on water. This explanation worked beautifully. It explained rainbows, reflections, refractions, and the gentle blending of colours in the sky. Then, unexpectedly, light began to act as if it arrived in small, indivisible packets. Experiments showed that light sometimes behaved not like a continuous wave, but like a series of tiny deliveries, each one carrying a specific, fixed amount of energy. You could turn the brightness up or down by sending more or fewer of these packets, but you could not split one in half. It was as if the ocean itself had decided to arrive not as a smooth tide, but as perfectly counted drops. Physicists tried to hold both pictures at once. Light, they said, is sometimes a wave, sometimes a particle. Depending on how you look, one description or the other takes the lead. This explanation worked well enough to move forward, but it carried a quiet discomfort. Reality was beginning to sound less like a solid structure, and more like a clever trick. Then electrons joined the rebellion. Electrons had always been thought of as particles, tiny charged objects moving from place to place. But when electrons were sent through carefully designed experiments, one at a time, they produced patterns that no single particle should be able to create. Over many repetitions, a delicate interference pattern emerged, the kind expected from overlapping waves. What made this unsettling was not just the pattern itself, but how it formed. Each electron arrived alone. There were no neighbouring electrons to interact with, and yet collectively they behaved as if each one had somehow spread out, explored multiple possibilities, and interfered with itself before settling on a final landing spot. The idea of a tiny solid object following a single well-defined path began to feel strained. Something about the old picture was missing a crucial ingredient. Atoms added another layer of quiet resistance. Early diagrams showed electrons circling the nucleus like planets around a star, each orbit neatly defined. But these images were always a compromise, a way to make something unfamiliar feel manageable. In reality, electrons refused to behave like orbiting points. They did not trace clean paths. They occupied regions. They formed patterns. And, most importantly, they did not gradually lose energy and collapse inward, as classical physics would predict. Atoms were stable not because electrons were obedient, but because they followed rules that had nothing to do with tiny balls in motion. As these observations accumulated, physicists were faced with an uncomfortable truth. The problem was not with individual experiments, the problem was with the foundation beneath them. The particle picture, comforting as it was, could no longer carry the weight being placed upon it. Yet notice something important here. Science did not respond with panic. There was no dramatic abandonment of everything that came before. Instead, there was a long period of careful adjustment, of holding contradictory ideas side by side, of admitting uncertainty without surrendering clarity. Particles still existed in the language of physics. Waves still existed too. But both began to feel like shadows cast by something deeper, something that did not fit neatly into either category. This is often where modern explanations become sharp and demanding, filled with equations and abrupt declarations. But there is a gentler way to approach what was happening. Rather than asking whether something is a wave or a particle, physicists slowly began to ask a different question. What if both are simply ways of describing behaviour, not the underlying thing itself? What if the universe is not built from objects that occasionally act like waves, but from something that naturally produces both behaviours depending on how it is disturbed? This shift in thinking is subtle, but profound. It moves us away from arguing about labels and toward understanding structure. Imagine watching the surface of a calm lake. If a leaf floats by, you can track it like an object. If a breeze passes over the water, you see waves ripple across the surface. The leaf and the wave are very different things, yet neither fully captures what the lake itself is. They are expressions, temporary observable patterns arising from something continuous beneath them. In this analogy, particles and waves begin to look less like competing explanations, and more like different ways the same underlying reality makes itself visible. The misbehaviour of particles was not chaos, it was consistency pointing toward a deeper order. Light arrived in packets because only certain disturbances were allowed. Electrons formed patterns because their behaviour was shaped by stable possibilities rather than fixed paths. Atoms remained intact because their structure was governed by rules that favoured balance and persistence, not mechanical motion. Slowly, quietly, a new idea took shape. One that did not discard particles but reinterpreted them. One that did not deny waves but gave them a more fundamental home. That idea was fields. Not fields as things added to space, but fields as the very fabric that gives space its character. Continuous, everywhere, patient, capable of remaining perfectly calm or of supporting precise countable disturbances. At this stage, we do not need to define fields precisely. We only need to feel why they became necessary. The universe was telling us, again and again, that it was not built from tiny beads in emptiness. It was built from something smoother, quieter, and more flexible. Something that could naturally give rise to both waves and particles without contradiction. As this realization settles, it becomes easier to let go of the urge to force reality into familiar shapes. The strange behavior of light and electrons is no longer a problem to be patched over. It is an invitation to look beneath appearances, and as we allow ourselves to follow that invitation, gently and without hurry, the solid world we thought we knew begins to soften, not into confusion, but into coherence. As the strange behaviors of light and electrons slowly became impossible to ignore, physics entered a long, reflective pause. Not a moment of confusion, but a moment of listening. The universe was not shouting that everything was wrong. It was whispering that something essential had been assumed too quickly. For generations, particles had been treated as the starting point. They were the nouns of reality, the solid things from which everything else was built. Motion, energy, and interaction were verbs added later. But as experiments grew more precise, it became harder to believe that these tiny objects were truly the foundation. They behaved too fluidly, too context-dependent, too sensitive to how they were observed. The problem was not that particles sometimes acted like waves. The deeper problem was that the distinction itself began to feel artificial. It was as if nature did not recognize the boundary humans had drawn between object and motion. This realization did not arrive suddenly. It unfolded through countless careful measurements and quiet recalculations. Each time physicists tried to describe what was happening using only particles as the base ingredients, they found themselves adding layers of explanation. Special rules, exceptions, mathematical fixes that worked but felt oddly strained. Over time, a pattern emerged. Whenever the descriptions became most elegant and stable, particles seemed to fade into the background. What took their place was something more continuous, more patient, and less concerned with being counted. This was the moment when the idea of a deeper foundation began to feel not just useful, but necessary. To understand why, it helps to step back from physics and think about explanation itself. When we describe waves on the ocean, we don't usually say that the water is made of waves. Waves are something water does. They are behaviors, not ingredients. They arise when conditions are right, and disappear when those conditions fade. The same is true of sound. Music is not built from notes in the way a wall is built from bricks. Notes are patterns of vibration travelling through air. They depend on the air, but they are not separate objects hiding inside it. Once you see the world this way, the puzzle of particles becomes gentler. What if particles are not the building blocks of reality, but the building blocks of our descriptions? What if they are the moments when something deeper organises itself into a stable, repeatable pattern? This shift in perspective does something subtle but powerful. It removes the pressure to force reality into rigid categories. Instead of asking whether something is a wave or a particle, we can ask what kind of underlying structure naturally produces both. And that structure, increasingly, pointed toward fields. A field is not an object you can hold. It is a way of assigning a value or behavior to every point in space. Temperature is a field. Wind speed is a field. Even the brightness of a room can be thought of as a field, changing gently from place to place. What made fields especially appealing in physics was not just their flexibility, but their calmness. Fields exist whether or not anything dramatic is happening. They do not require particles to be present in order to be real. They simply are. In this emerging view, the universe is not a stage filled with actors. It is more like a landscape of possibilities. Most of the time, nothing noticeable happens. The fields remain quiet, resting in their lowest, calmest states. But when energy enters the picture, when conditions shift just enough, those fields respond. They ripple, they vibrate. And in certain special cases, those vibrations become stable enough to persist, countable enough to track, familiar enough to earn names. Those are the moments we call particles. Seen this way, particles stop feeling mysterious. They are no longer tiny objects darting through emptiness. They are events, they are patterns, they are the universe briefly speaking in a way we can count and measure. This idea also helps explain why particles appear and disappear so easily. In many experiments, particles are created from energy and later vanish back into it. If particles were truly fundamental objects, this would feel unsettling. But if they are patterns in a deeper structure, then creation and disappearance are simply changes in how that structure is excited. Nothing essential is being lost. Nothing is being conjured from nothing. The fields remain, only their patterns change. This quieter foundation also brings a kind of emotional relief to physics. Instead of imagining a universe constantly buzzing with tiny objects colliding and rebounding, we can imagine something smoother, a vast, continuous presence, mostly still. Motion becomes the exception, not the rule. And importantly, this picture does not erase the solid world we experience. Tables still resist our hands, atoms still form molecules, materials still hold their shape, but solidity becomes an emergent quality, not a fundamental one. It is what stability feels like when patterns persist long enough to matter to us. At this stage, we don't need to know the detailed mathematics behind fields. We don't need to describe how they are written in equations or how their vibrations are calculated. Those details belong to another kind of conversation, one that asks for focus and alertness. Here, it is enough to recognize why the shift was needed. The universe did not grow more complicated as physics progressed. In many ways, it grew calmer. The frantic dance of particles softened into a steady background where change happens in measured steps, and excitement stands out against a wide field of quiet. This is the foundation we will continue to build upon, a universe where continuity comes first, where patterns emerge gently, where the things we can count are simply the visible notes in a much larger, quieter composition. As this idea settles, it prepares us to understand what fields really mean, not as abstract constructs, but as something deeply intuitive, something already present in how we experience the world, even if we haven't named it that way before. By the time the idea of fields began to feel like a natural foundation for physics, something quietly reassuring became clear. Fields were not strange inventions created only for advanced science. In fact, they had been part of our everyday experience all along. We'd simply never paused to think of them that way. Consider temperature. Walk from a shaded room into sunlight and you feel the change immediately. Move your hand closer to a warm cup of tea and the sensation grows stronger. Temperature is not something that exists only inside objects. It is a property assigned to every location in space, rising and falling smoothly from one place to another. Even in an empty room, temperature is present everywhere, quietly describing how energetic the air is at each point. Wind works the same way. It is not a collection of tiny invisible objects rushing past you. It is a pattern of motion spread across space. At one corner of a field, the air may be still. A few steps away, it may be moving steadily. Farther out, it may swirl and change direction. The wind is not something you can pick up or isolate, yet its presence is unmistakable. It exists as a relationship between space and motion. Pressure too belongs to this quiet family. It presses on your skin evenly, without shape or edge. It does not arrive in lumps or pieces. It is simply there, changing gently with altitude, weather, and depth. These are all examples of fields, though we rarely call them that in daily conversation. What matters is not the name, but the structure. A field assigns meaning to every point in space. It tells you something about what is happening there, even if nothing dramatic is occurring. This idea helps soften the leap from everyday experience to fundamental physics. When physicists speak of fields filling the universe, they are not introducing an alien concept. They're extending a familiar one. Now imagine turning off all lights in a room. The room grows dark, but it does not cease to exist. Temperature remains, air pressure remains, space continues to have structure, even in the absence of visible objects. Darkness is not emptiness. It is simply the absence of a particular kind of activity. In the same way, modern physics suggests that even when no particles are present, the underlying fields remain. They do not vanish when nothing is happening. They are woven into the universe itself. This realization quietly dissolves the idea of empty space as a true void. Instead of picturing vast regions of nothingness, punctuated by tiny bits of matter, we begin to picture a continuous backdrop, always present, always ready to respond. One of the most calming aspects of this picture is its patience. Fields do not rush, they do not demand attention. Most of the time, they remain in their lowest, calmest states. Only when energy enters, through interaction, motion, or disturbance, do they begin to show visible behavior. This is where the connection to particles becomes clearer, without needing to force it. If a field is calm everywhere, nothing stands out. But if a field is disturbed in just the right way, a localized pattern can appear. Something countable, something repeatable. Before we go there, it helps to linger on one subtle point. Fields do not need objects in order to exist. Temperature exists even where there is nothing warm nearby. Wind exists even if there are no leaves to reveal it. Pressure exists even if nothing presses back. Likewise, fundamental fields exist even when they are not being excited into particles. They are not created by particles. They are the stage upon which particles appear as special events. This shift reverses the usual intuition. Instead of imagining fields as things generated by particles, we begin to imagine particles as things generated by fields. Another comforting aspect of fields is how naturally they handle change. Fields can vary smoothly, they can remain steady, they can respond locally without needing instructions from afar. This makes them ideal candidates for describing a universe that is both orderly and flexible. It also explains why early particle-based descriptions became strained. When you try to build a continuous world from discrete pieces alone, you end up constantly patching the gaps. Fields remove those gaps by design. At this point, the idea of fields no longer feels abstract. It feels like a familiar way of describing how the world behaves, simply extended to deeper layers of reality. And yet, there is an even deeper step waiting. The fields we have described so far, temperature, wind, pressure, are things we experience through matter. They rely on atoms and molecules to exist. Fundamental fields go one step further. They do not depend on matter. Matter depends on them. This inversion is quiet but profound. It suggests that the solidity we experience is not the foundation of reality, but a surface effect. Beneath it lies a continuous fabric that is far less rigid, yet far more stable. As this idea settles, it prepares us to address a natural question. If fields are everywhere and if they are continuous, how do we ever get discrete, countable things like particles? How does smoothness give rise to steps? How does quiet give rise to events? The answer will not arrive as a sudden revelation. It will emerge gradually through images of vibration, rhythm, and allowed patterns. But before we move there, it is worth appreciating how gentle this foundation already is. A universe built from fields is not a chaotic place. It is not crowded with invisible objects racing endlessly through space. It is spacious, it is calm, and it is capable of producing complexity without losing its underlying simplicity. As we rest in this picture for a moment, the idea of particles begins to loosen its grip. Not because particles are unreal, but because they are no longer alone. They are expressions of something broader, something quieter, and something already familiar if we take the time to notice. Once we begin to feel comfortable with the idea of fields as something familiar and ever-present, another long-held assumption starts to loosen quietly in the background. It is the idea that space itself is empty. Not empty in the casual sense of a quiet room, but empty in the deeper sense of having nothing at all inside it. For a long time, this image felt natural. Space was imagined as a vast, silent container. Matter lived inside it. Light crossed it. Forces reached through it. But space itself was thought to contribute nothing. It was simply there, like an invisible stage waiting for something to happen. This picture is deeply rooted in everyday experience. When you remove furniture from a room, the room feels empty. When the sky is clear and still, the air feels like nothing at all. Our senses are very good at detecting presence, but not so good at detecting quiet structure. Yet even in the most ordinary situations, emptiness is rarely as empty as it seems. A quiet room still has temperature. It still has air pressure gently touching your skin. It still carries faint sounds, distant vibrations, and subtle movements you may not notice unless you stop and listen. Darkness, too, is often mistaken for absence. When the lights are off, the room feels empty of activity, but the space itself remains unchanged. The walls are still there. The air still fills the room. The structure has not disappeared, only the visible signals have faded. Modern physics suggests that the same is true of space itself, even far beyond the rooms and skies we know. What we call empty space is not a void stripped of content. It is a region where the underlying fields are resting quietly, not being excited into anything we can easily detect. This is a subtle shift, but an important one. It means that space is not defined by what is missing, but by what is present in a calm form. In this view, removing all particles from a region does not leave behind nothing. It leaves behind the fields in their lowest, most peaceful states. These states are not dramatic. They do not flash or glow. They simply persist, providing the possibility of a future motion, interaction, and structure. One way to imagine this is to think of a perfectly still ocean at dawn. No waves are visible, no ripples disturb the surface, and yet the ocean is fully present. Its depth, its weight, its ability to support motion have not vanished. They are simply resting. Empty space. In the modern picture is like that calm ocean. The fields that define reality are still there, evenly spread, quietly holding their form. This perspective helps explain something that once puzzled physicists deeply. Particles can appear and disappear. Light can be created from energy and later absorbed. Matter can transform. But throughout all of this, the underlying framework remains unchanged. The universe does not tear or unravel when particles vanish. The fields remain steady, ready to support new patterns. It also explains why space behaves consistently across immense distances. The same rules apply near Earth and between galaxies. The same kinds of fields exist everywhere, not because something placed them there, but because they are part of what space is. Importantly, this does not mean that space is busy or crowded. Quite the opposite. Most of the universe is astonishingly quiet. Vast regions contain no stars, no dust, no visible motion. Yet even there the fields are present, calm and uniform. This quiet presence gives space its stability. It ensures that when something does happen, when energy enters a region, when fields are disturbed, the response is predictable and orderly. Patterns form according to rules that are already in place, not improvised on the spot. At this stage, it may be tempting to imagine fields as invisible substances filling space like fog or mist. But even that image goes a little too far. Fields are not things poured into space. They're better thought of as the way space itself behaves. Every point in space carries information about how it can respond, what kinds of vibrations are allowed, what kinds of interactions can occur. Space is not passive, it is structured. This idea becomes especially gentle when we remember that structure does not imply activity. A calm field is not doing anything wrong by being still. Stillness is its natural state. Activity is the exception. This helps dissolve the lingering discomfort that often accompanies modern physics. The universe is not constantly jittering with unpredictable motion. It is not packed with restless entities darting endlessly through the void. It is, for the most part, settled. When particles appear, they do so against this background of calm. They are noticeable precisely because they are rare and localized. They stand out like brief ripples on an otherwise smooth surface. As this picture settles in, the idea of empty space begins to feel outdated rather than mysterious. Space is not a container waiting to be filled. It is already full of potential, already shaped by fields that define what can happen there. This prepares us for a deeper insight that will unfold naturally from here. If space itself carries structure, then fields are not guests inside it. They are expressions of its nature. And if that is true, then the particles we observe are not intruders in emptiness, but gentle excitations of a reality that is already present everywhere. We do not need to rush forward to make this precise. For now, it is enough to let the idea rest quietly. Empty space is not empty. It is calm. And calm, as we are slowly discovering, is one of the universe's most important qualities. As the idea of non-empty space begins to feel more natural, another quiet adjustment follows. It is an adjustment that does not demand effort, but simply a willingness to release one last familiar image, the image of space as a container and fields as things placed inside it. This image is understandable. We're used to containers. Rooms hold furniture, boxes hold objects. Even the sky, in our imagination, holds clouds and birds and light. It feels intuitive to think of space as a vast version of the same idea, and of fields as invisible substances filling that space. But modern physics gently suggests something different, something calmer and more integrated. Fields are not contents poured into space. They are not occupants renting room inside an empty volume. They are closer to rules than to objects. They describe how each point of space is allowed to behave. To sense the difference, imagine a chessboard. The board itself does not contain the rules of chess as objects. The rules are not stored in a square or tucked beneath the surface. And yet, without the rules, the board is meaningless. Every square's significance comes from how it is allowed to participate in the game. In a similar way, fields are woven into space so deeply that separating the two no longer makes sense. Space is not first created and then filled with behavior. Space and behavior arise together as one structure. This may sound abstract at first, but there are gentler ways to feel it. Consider a stretch of open ground. The ground does not contain gravity as a separate thing. Gravity is simply how objects behave when placed there. It is not stored somewhere hidden beneath the soil. It is part of the way that region of space responds. Now imagine removing every object from that space. Gravity does not disappear. The rules remain, even when nothing is actively following them. Fields operate in much the same way. They are present even when nothing is happening. They define possibilities rather than outcomes. They tell space how it can respond, long before anything asks it to. This perspective explains something that once felt puzzling. Why do the same physical laws apply everywhere? Why does an electron behave the same way near Earth as it does near a distant galaxy? The answer is not that particles carry their rules with them. The answer is that the rules are already there, embedded in space itself. When physicists speak of an electron field or an electromagnetic field, they are not describing a substance that flows through space. They are describing a consistent way that space responds to certain kinds of disturbances. These responses are so reliable that they can be counted, predicted, and named. This is why fields feel so stable. They do not age. They do not weaken over time. They do not need energy simply to exist. They are not processes unfolding in time. They are the backdrop that makes processes possible. At this point, it becomes easier to understand why the universe does not need constant maintenance. Nothing is holding the fields together. Nothing is refilling space as it empties. The structure simply is. This idea also helps explain why fields can remain perfectly calm for long periods. A calm field is not failing to do anything. It is doing exactly what it does best, quietly maintaining the rules of engagement. Only when energy enters the picture do fields reveal themselves in more dramatic ways. A disturbance is introduced. A vibration begins. Space responds according to the rules already written into it. From this perspective, particles feel less like travelers moving through space, and more like conversations between energy and structure. Energy asks a question. The field answers with a pattern. This also helps dissolve the idea that fields are constantly buzzing with activity. They are not restless, they are patient. Most of the time, they are still. This stillness is not emptiness, it is readiness. There is a gentle beauty in this picture. The universe does not need to scramble to create order. Order is already present, quietly waiting. Complexity emerges not from chaos, but from subtle deviations from calm. As we sit with this idea, it becomes clear why modern physics finds fields so fundamental. They offer a way to describe reality that is continuous, stable, and deeply economical. Instead of tracking countless tiny objects and their individual motions, physics can describe how space itself behaves. This does not make particles disappear from our experience. We still detect them, we still count them, we still build technology around them, but their role shifts. They become signals, not foundations, and this shift does something quietly profound to how the universe feels. Reality no longer seems like a cluttered warehouse of invisible objects. It feels spacious, structured, calm. As this understanding settles, it prepares us for the next gentle step. If fields are woven into space itself, and if they respond to disturbances in consistent ways, then the patterns they form are not arbitrary. Some vibrations persist, others fade, some motions repeat, others dissolve, and from this natural selectivity something remarkable emerges: discrete, stable patterns, countable excitations, the things we call particles. We do not need to rush ahead to grasp this fully. The idea will unfold slowly, carried by images of motion, rhythm, and rest. For now, it is enough to recognize that fields are not residents of space. They are the quiet rules that give space its character. Once we begin to see fields as the quiet structure of space itself, a natural question arises, almost on its own. If fields are always present, calm and steady, what happens when they are disturbed? What does motion look like in a universe built not from objects, but from continuous structure? The answer is surprisingly gentle. A field does not react to disturbance with violence or confusion. It responds the way a calm surface responds when something touches it. Imagine a still pond early in the morning. The water is smooth, reflective, almost perfectly at rest. Drop a small stone into it and nothing breaks. The water does not shatter. Instead, a pattern appears. Rings spread outward, evenly spaced, growing softer as they travel. The pond has not changed its nature. It has simply allowed motion to pass through it. Fields behave in much the same way. When energy enters a field, the field does not produce objects. It produces movement, a local change, a vibration that spreads according to the rules already built into the structure of space. This way of thinking shifts our intuition in an important direction. Motion is no longer something carried by an object. Motion is something that happens within a field. In daily life, we are used to attaching movement to things. A car moves down a road. A ball travels through the air. A bird crosses the sky. But beneath these familiar experiences, there is always a field at work. Sound moves through air as vibrations. Heat spreads through materials as shifting energy. Water waves travel without transporting water itself across the entire distance. Once you notice this, motion begins to feel less mysterious and more universal. Movement does not require objects to migrate from one place to another. It requires a medium capable of responding locally and passing that response along. In the field-based view of reality, this medium is space itself. When a field is disturbed, the disturbance does not leap instantly across the universe. It moves gradually, guided by the structure of the field. Each point in space responds to its neighbours, passing the change along smoothly, like a message whispered from one location to the next. This is why motion in fields often appears wave-like. Waves are not things, they are coordinated patterns of change. Each part of the field follows simple rules, and together they produce a graceful, flowing behaviour. At this stage, it is tempting to imagine fields constantly rippling, like a restless ocean. But this image would be misleading. Most of the time, fields remain still. Disturbances are rare. Motion is the exception, not the rule. This quietness is important. It ensures that when motion does occur, it stands out clearly against a calm background. Patterns are not drowned in noise. They are clean, precise, and stable. When fields begin to move, they do so in a controlled way. They do not allow arbitrary motion. Just as a guitar string can vibrate only in certain patterns, fields permit only specific kinds of movement. These patterns are shaped by the properties of the field itself. Think again of a musical instrument. When a string is plucked, it does not vibrate randomly. It produces a tone. That tone may be rich and complex, but it is built from a small set of allowed vibrations. The instrument structure determines what sounds are possible. Fields act like instruments on a cosmic scale. Their structure determines what kinds of vibrations can exist, how fast they travel, and how they interact with one another. This idea may feel abstract, but it is deeply intuitive. Even a simple rope, when shaken, will not form every imaginable shape. Some motions fade immediately, others reinforce themselves and persist. Stability arises not from effort, but from compatibility with the underlying structure. In the same way, when a field is disturbed, most possible motions fade quickly. Only certain patterns survive. These surviving patterns are the ones we will eventually recognize as particles. But before we get there, it is important to sit with the motion itself. A moving field is not chaotic, it is expressive. It reveals what the field allows. This perspective also helps clarify why energy and motion are so closely linked. Energy is not something stored inside a particle like fuel in a tank. Energy is the capacity to disturb a field. When energy is present, fields respond. When energy is absent, fields rest. Nothing about this process requires sharp boundaries or solid edges. Motion spreads naturally. Patterns emerge organically. Stability is earned through harmony with the field structure, not through rigidity. This view removes a great deal of tension from our understanding of the universe. We no longer need to imagine countless tiny objects constantly colliding and bouncing. Instead, we can imagine a mostly quiet reality where occasional disturbances create ripples of activity that travel, interact, and eventually fade. And yet, some disturbances do not fade quickly. Some patterns repeat. Some vibrations hold their shape as they move. These special cases will soon become central to our story. For now, it is enough to appreciate the calm logic of motion in fields. Fields move not because they must, but because they can. They respond gracefully to change, guided by rules that are already in place. As this idea settles, motion begins to feel less like something added to reality and more like something revealed. The universe does not need to be pushed into action. It already knows how to move, quietly and precisely whenever the moment arrives. As we grow more comfortable with the idea of fields responding gently to disturbance, another quiet realization begins to take shape. Fields do not accept just any kind of motion. They are selective. Out of countless imaginable ways a field could move, only a small number are permitted to last. This selectivity is not strict or forceful. It is natural. It arises from the structure of the field itself. To feel this intuitively, it helps to return once more to familiar experiences. Imagine holding a long rope, fixed firmly at both ends. If you shake it wildly, the rope does not freeze into random shapes. Most of the motion you introduce disappears almost instantly. The rope settles into a few simple patterns, steady and repeatable, where the motion reinforces itself instead of cancelling out. These patterns are not chosen by the rope out of preference. They are chosen by compatibility. Only certain motions fit the constraints of the rope's length, tension, and attachment points. Everything else fades. The same is true of a drumhead. When struck, it vibrates in complex ways, but those vibrations are not limitless. They form distinct tones, clear notes. Each one is a stable pattern that the drumhead can support without tearing itself apart. Fields behave in exactly this way, though on a scale far removed from ropes and drums. When a field is disturbed, it briefly explores many possibilities, but almost all of them dissolve. Only a few patterns remain coherent long enough to matter. This is a crucial step in understanding why the universe feels orderly rather than chaotic. Stability does not need to be imposed from outside. It emerges automatically when only certain motions are allowed to persist. This idea is often described with a word that sounds technical and sharp, but the meaning behind it is gentle. That word is quantization. Instead of thinking of it as a mathematical rule, it can be felt as a musical one. Quantization means that changes happen in clean steps, like notes on a scale, rather than sliding continuously between all possibilities. A field does not produce an infinite blur of motions. It produces distinct, recognizable patterns. Importantly, this discreteness does not come from hardness or rigidity. It does not mean the field is made of blocks or pixels. It means that the field prefers harmony over noise. Imagine a choir humming softly. Individual voices may waver slightly, but the overall sound settles into clear tones. The room does not fill with every possible pitch. It fills with the ones that resonate. Fields resonate in much the same way. This resonance explains something that once seemed deeply puzzling. Why does energy appear in fixed amounts when we measure it? Why do atoms absorb or release energy in sudden jumps rather than smooth fades? The answer is not that nature is abrupt or digital at its core. The answer is that fields only allow certain vibrations to remain stable. When a field shifts from one stable pattern to another, the change appears sudden, like stepping from one note to the next. Between those notes, nothing can linger. This also helps explain why the universe is not overflowing with strange half-formed particles. If every imaginable vibration could persist, reality would be crowded and chaotic. Instead, only a limited set of patterns survive. These patterns are consistent, repeatable, and predictable. They form the alphabet of the physical world. At this point, it becomes easier to understand why early attempts to describe particles as tiny objects struggled so much. Objects can, in principle, move in any way. Fields cannot. Their behavior is constrained by their structure. This constraint is not a limitation, it is a gift. It allows complexity to arise without confusion. It allows atoms to exist. It allows light to carry information. It allows matter to hold its shape. Another gentle way to feel this is to think about walking across stepping stones in a stream. You cannot place your foot just anywhere. Only certain stones can support your weight. Each step is discrete, but the path as a whole is smooth and navigable. Fields offer stepping stones for motion. They do not allow endless sliding. They allow stable resting points. This idea prepares us for an important shift in language. When we say that a particle exists, what we are really saying is that a field has found a vibration it can support. A vibration stable enough to travel, stable enough to be counted, stable enough to interact. Particles are not exceptions to the smoothness of fields, they are expressions of it. This also means that the strange discreteness of the microscopic world is not a mystery layered on top of an otherwise continuous reality. It is a natural outcome of continuity combined with constraint. Smoothness and discreteness are not opposites here. They are partners. As this understanding settles, the universe begins to feel less mechanical and more musical. Reality is not assembled from rigid parts. It unfolds through allowed patterns, guided by harmony rather than collision. And importantly, nothing about this picture requires us to introduce sharp symbols or abstract formulas. The behavior emerges naturally from structure. The rules are felt rather than imposed. In the quiet background of space, fields rest. When disturbed, they explore possibilities. And from those possibilities, only certain vibrations remain, clear and enduring. These are the vibrations we're beginning to recognize. Soon we will give them names. We will trace how they move, how they interact, and how they build the familiar world around us. For now, it is enough to rest with the idea that not every vibration is allowed. Order does not need to be enforced. It arises gently, as fields choose harmony over noise. By now, the idea that not every vibration is allowed may feel less strange than it once did. Fields, like instruments, naturally settle into patterns that fit them. Some motions fade, others endure. From this gentle selectivity, the world gains its order. Yet there is still a lingering question, one that quietly waits beneath the surface. Why do these allowed patterns feel so precise? Why does nature seem to count them, rather than letting them blur together? This question often leads directly into mathematics, into symbols and compact expressions that can feel sharp and demanding. But before any of that is needed, there is a softer way to understand what is happening. Imagine turning a dimmer switch in a room. In an idealized world, the light might smoothly slide from dark to bright, passing through every possible level in between. But now imagine a different kind of switch, one that clicks through a small number of stable settings. off, low, medium, high. Each position is comfortable and reliable. Between them there is nothing to rest on. This second switch does not feel broken or crude. It feels intentional. It offers clarity instead of ambiguity. Quantization is nature's version of that second switch. When a field vibrates, it does not glide through every possible intensity. It settles into specific, stable patterns. Each pattern carries a fixed amount of energy, like a step on a staircase rather than a slope on a hill. What matters here is not the counting, but the stability. Fields prefer patterns that reinforce themselves. Once such a pattern forms, it resists small disturbances. It persists long enough to be noticed. This is why energy exchanges in the microscopic world often feel sudden. An atom does not gradually leak light as it drifts from one condition to another. It holds its pattern quietly and steadily until it shifts to a new one. That shift appears as a clean change, a single event rather than a slow fade. This behavior once seemed abrupt and mysterious, as if nature were making arbitrary jumps. But in the field-based picture, it becomes gentle and logical. The field is not jumping, it is moving from one stable rhythm to another. Between those rhythms, there is simply no place to linger. It is important to notice what quantization does not mean. It does not mean that reality is built from tiny rigid blocks. It does not mean that space is chopped into pixels or that energy is granular in a mechanical sense. Quantization arises from continuity, not from fragmentation. A violin string is continuous from end to end, and yet when it vibrates, it produces distinct notes. The discreteness comes from the way the string must fit its boundaries, not from the string being made of separate pieces. Fields behave in exactly this way. They're continuous everywhere. Their allowed vibrations are discrete because only certain patterns are compatible with their structure. This perspective dissolves one of the oldest confusions in modern physics. Discreteness does not oppose smoothness, it emerges from it. Once this is understood, many strange features of the quantum world begin to soften. The fact that energy comes in packets no longer feels like an arbitrary rule. It feels like the natural consequence of resonance. The fact that particles can be counted no longer feels like proof that they are solid objects. It feels like evidence that they are stable patterns. Even the idea of measurement becomes gentler. When we measure something in the quantum world, we're not forcing a vague reality to snap into place. We're discovering which stable pattern the field has chosen to occupy. This also explains why repeated measurements yield consistent results. A stable pattern does not randomly change its identity. It remains what it is until conditions shift enough to support a different one. In this sense, quantization brings a deep kind of reliability to the universe. It ensures that the same patterns appear again and again across time and space. It allows atoms formed billions of years ago to behave the same way as atoms today. It allows light emitted from distant stars to follow the same rules as light produced in a laboratory. This consistency is not imposed from above. It arises naturally from the structure of fields. There is something quietly comforting in this idea. The universe does not need to constantly decide how to behave. It does not roll dice at every moment. It follows rhythms that are already written into its fabric. At this stage, it may help to let go of the word quantum itself, with all the tension it often carries. What we're describing is not a world of mystery for its own sake. It is a world of allowed patterns. Patterns that are gentle enough to repeat. Patterns that are stable enough to last. Patterns that are simple enough to build complexity upon. Seen this way, the strange rules of the microscopic world stop feeling alien. They feel inevitable. The field vibrates. Most motions fade. Some remain. Those that remain come in distinct forms. Those forms are what we observe as discrete events. This is the heart of quantization, expressed without symbols or formulas. Not as a rule to memorize, but as a natural outcome of harmony and constraint. As this understanding settles, we are ready to take another step. If fields support stable, countable vibrations, then those vibrations can travel, they can interact. They can combine to form larger structures. In other words, the allowed notes of fields can begin to play together, and when they do, the world we recognize, light, matter, and all the quiet complexity between, starts to emerge in a way that feels less strange and more like a carefully composed piece of music. By the time we reach this point, something subtle has already shifted. The idea of fields no longer feels abstract, and vibrations no longer feel strange. What remains is a final habit of thought, one that has been with us since childhood, the habit of picturing particles as tiny things, small solid nuggets moving through space, bumping into one another like grains of sand. Letting go of this image does not mean rejecting what we observe. Detectors still click, screens still light up at precise spots. Experiments still count individual events. What changes is not the evidence, but the interpretation we place beneath it. In the field-based picture, a particle is not a little object travelling from place to place. It is a stable ripple, a self-sustaining pattern that the field can support over time. It is something the field is doing, not something the field contains. This distinction matters more than it first appears. When we imagine particles as objects, we naturally assume they must have sharp boundaries, an inside and an outside, a definite location at every moment. But the behaviour we have already encountered does not fit comfortably within those assumptions. Particles spread, they interfere, they appear and disappear. They behave less like pebbles and more like events. A ripple, by contrast, has no solid edge. It is localised, but not confined. You can point to where it is strongest, but not to a precise boundary where it ends. It persists not because it is rigid, but because it is supported by the medium beneath it. Think again of a wave travelling across water. The wave moves, yet no single portion of water makes the entire journey. The wave is a pattern that carries energy and information, not a lump of substance migrating through space. When the pattern fades, nothing essential has vanished. The water remains. A particle, in this gentler picture, behaves in much the same way. It is a pattern travelling through a field. The field remains everywhere. The particle is the recognisable motion. This helps explain why particles can be created and destroyed without tearing reality apart. When energy disturbs a field in the right way, a ripple forms. When that disturbance settles, the ripple fades. Nothing fundamental has been added or removed, only the pattern has changed. It also explains why particles are countable. Patterns that are stable tend to come in recognisable units. You can have one ripple or two, or none at all. You cannot have half of a stable pattern lingering on its own. Counting particles is really counting how many stable excitations are present. In this sense, particles are not objects you collect, they are events you tally. This idea may feel unsettling at first, but it brings with it a quiet order. Instead of imagining a universe crowded with countless tiny things, constantly jostling for space, we can imagine a largely calm structure where only certain motions stand out. Order emerges not from solid pieces snapping together, but from permitted motion repeating itself reliably. This perspective also reshapes how we think about interaction. When two particles interact, it is not two objects colliding like billiard balls. It is two patterns overlapping within a field. Their interaction is governed by how the field allows patterns to combine, reinforce, or cancel. Seen this way, interaction feels less violent and more conversational. patterns meet, the field responds, new patterns may form while others fade. Importantly, none of this denies the effectiveness of particle language. Physicists still speak of particles because the language is useful. It allows predictions to be made. It allows experiments to be designed. It allows technology to function. But usefulness does not always imply fundamentality. Calling a ripple a particle is like calling a melody a thing. It is convenient shorthand, but it misses the deeper structure beneath it. Once this distinction settles in, many familiar puzzles soften. The strange duality of wave and particle stops feeling like a contradiction. A ripple can behave like a wave when spreading out, and like a particle when counted, without needing to choose one identity over the other. The question, is it a wave or a particle, quietly dissolves. The answer becomes it is a pattern. This also helps us understand why the microscopic world feels so different from the solid world we experience. At large scales, countless patterns overlap, interact, and stabilize. Their combined behavior produces solidity, resistance, and weight. At small scales, individual patterns stand out, revealing the fluid nature beneath. Nothing about this picture diminishes the reality of matter, it deepens it. What feels solid to us is not made solid by tiny bricks. It is made stable by persistent motion. There is something gently poetic in this idea. Stability does not come from stillness, it comes from balance. A spinning top remains upright not because it is motionless, but because its motion is well arranged. Particles are like that. They persist not by being rigid, but by moving in exactly the way the field allows them to move. As this understanding settles, the world feels a little less cluttered and a little more spacious. Reality is no longer a warehouse of objects. It is a landscape of patterns, most of them calm, a few of them active, all of them shaped by the same underlying structure. This prepares us naturally for the next step. If particles are ripples, then light becomes the simplest example to explore. A ripple that moves freely, effortlessly, across the vastness of space, carrying rhythm rather than substance. But for now, it is enough to rest with this single idea. A particle is not a thing. It is a stable ripple in a field, a permitted motion that endures just long enough to be noticed. Once we loosen our grip on the idea of particles as tiny things, light becomes easier to understand than it ever was before. Light has always resisted being treated like a solid object. It slips through space effortlessly. It reflects, bends, spreads, and overlaps. And yet, when measured, it arrives in neat, countable moments. In the field-based picture, this mixture of behaviours no longer feels contradictory. Light is not a stream of little beads flying through emptiness. It is a travelling ripple in a field that is already everywhere. This field is known as the electromagnetic field. Rather than imagining it as something added to space, it helps to imagine it as a natural property of space itself. Every point in the universe carries the possibility of responding electrically and magnetically. Most of the time, this possibility rests quietly, unnoticed. But when the field is disturbed, something remarkable happens. A ripple forms. That ripple moves, not because it is being pushed, and not because it has mass that carries it forward, but because the field passes the disturbance from one point to the next. Each location responds to its neighbour, creating a coordinated motion that travels smoothly across space. This is what a photon is in its gentlest description. A photon is not a tiny object crossing a distance. It is a moving pattern of excitation in the electromagnetic field. Seen this way, many old puzzles begin to soften. Light does not need a vehicle to carry it, because it is not a passenger. It is the motion itself. It does not slow down because there is nothing dragging it through space. It travels at a speed set by how the field responds, not by how hard it is pushed. This speed is not something light chooses. It is something the structure of the field allows. The electromagnetic field has a built-in rhythm, a natural pace at which disturbances propagate. Light simply follows that rhythm. Another long-standing mystery also becomes gentler in this picture. Light sometimes spreads out like a wave, filling space, bending around obstacles, overlapping with itself. Other times, it arrives in precise, localized interactions, leaving a single mark on a detector. As a ripple, light can do both without confusion. The ripple spreads across the field, exploring many paths, but when it interacts, it does so as a whole. The field settles, and the pattern leaves a single countable trace. There is no need to imagine light splitting itself into fractions or choosing one path over another at the last moment. The ripple evolves according to the field structure, and the interaction reveals one complete outcome. Frequency, another word often wrapped in symbols and charts, can also be softened here. Instead of thinking of frequency as a number or a label, it can be felt as rhythm. A fast ripple carries a quick rhythm. A slower ripple carries a gentler one. The electromagnetic field responds differently to different rhythms, and those responses are what we perceive as colour, warmth, or signal. Colour, then, is not something painted onto light. It is the field's way of responding to a particular rhythm of motion. Warmth is another rhythm, slower and less visible, but no less real. This rhythmic view helps connect light to everyday experience. Music changes not because notes are heavier or lighter, but because their rhythms differ. Light changes not because photons carry colour like paint, but because their motion through the field has a different tempo. Light also becomes easier to understand as a messenger. When information travels using light, nothing is physically carried from sender to receiver. No substance makes the journey. What travels is a pattern of motion, a ripple whose rhythm has been carefully shaped. This is why light can cross vast distances without wearing out. The ripple does not age, the field does not tire. As long as the pattern remains coherent, it can travel across space with the same clarity with which it began. There is something deeply calming in this idea. The universe does not rely on tiny couriers rushing back and forth. It relies on a shared structure that allows motion to flow smoothly, like a whispered message passed gently along a line. This picture also explains why light can pass through empty regions of space with no resistance. There is no friction because there is nothing being dragged along. The field itself is responding step by step without loss. At the same time, light interacts readily when conditions allow. When the ripple meets matter, it can be absorbed, reflected, or reshaped. These interactions are not collisions between objects, they are conversations between patterns. The electromagnetic field overlaps with other fields, especially those associated with charged matter. When their patterns align in certain ways, energy is exchanged. The ripple may fade, and a new pattern may take its place. Nothing violent occurs, nothing breaks. Patterns simply transform. This understanding also brings clarity to why light feels both delicate and powerful. A gentle ripple can warm your skin. A carefully concentrated one can cut metal. The difference lies not in the existence of light, but in the rhythm and structure of its motion. As we rest with this picture, light begins to feel less like a mystery and more like a natural expression of the field beneath it. It is motion without mass, energy without cargo, information without substance, and yet, despite its lightness, it is precise. It arrives in countable events. It obeys strict rules. It behaves the same way across the universe because the field it moves through is the same everywhere. This prepares us to take another step. If light is a travelling ripple, then matter must be something slightly different, something more settled, something whose patterns do not race across space, but instead arrange themselves into persistent structures. With that thought gently forming, we can begin to explore how electrons and atoms emerge as stable patterns, and why solidity itself turns out to be a particular kind of motion, patiently held in place. After spending time with the light as a travelling ripple, it becomes natural to wonder how matter fits into this picture. Light moves freely, spreading across space with ease. Matter, by contrast, feels anchored. It gathers, it resists, it holds its shape. At first glance, matter seems to return us to the idea of solid things. But in the field-based view, matter is not a return to solidity. It is a different kind of motion. Matter is what happens when patterns in fields do not rush across space, but instead settle into place. To sense this gently, imagine a spinning whirlpool in a river. The water itself continues to flow downstream, but the whirlpool remains in roughly the same location. It is not made of a separate substance. It is a stable pattern formed by the motion of water responding to constraints. As long as the conditions are right, the pattern persists. Change the flow and the whirlpool fades. Electrons behave in a similar way, though in a far subtler field. An electron is not a tiny dot circling an atomic centre like a planet. It is a stable mode, a standing pattern that the electron field can support in the presence of other fields. Early diagrams of atoms showed electrons tracing neat orbits because that image felt familiar. But in reality, electrons do not travel along little tracks. They form patterns that spread out, overlap, and settle into shapes that remain steady over time. These patterns are not chosen arbitrarily. They are the allowed arrangements of motion within the combined fields of the atom. Only certain configurations are stable. Only certain rhythms can persist without dissolving. This is why atoms behave like instruments. Each atom has a set of tones it can play. When energy enters the system, the atom does not respond with random noise. It shifts from one stable pattern to another. When it settles again, it may release energy as light, carrying away the difference in rhythm. Emission and absorption, then, are not sudden tricks. They are changes in pattern. The atom retunes itself, and the field responds with a ripple that travels outward. This perspective removes the need to imagine electrons jumping between invisible ladders or snapping between rigid levels. The language of jumps can remain, but beneath it lies a smoother process. One pattern gently gives way to another, guided by what the fields allow. Now consider why matter feels solid. If matter were made of tiny hard pieces, solidity would come from contact between surfaces. But in the field-based picture, solidity arises from stability and resistance to change. The patterns that make up matter are not easily disturbed. When you press your hand against a table, you're not touching a collection of little blocks. You're encountering a network of stable patterns that resist being rearranged. This resistance feels solid because it is reliable. The fields involved prefer their current arrangements. Pushing against them requires energy. The patterns push back not out of stubbornness, but out of balance. This also explains why matter can be both firm and flexible. Bend a piece of metal, and the patterns shift slightly, finding new stable arrangements. Push too far, and the patterns break apart, forming different ones entirely. The material changes, but the underlying fields remain. Matter's apparent stillness is therefore deceptive. Beneath every solid object lies continuous motion, carefully arranged so that nothing appears to move. Stability hides activity. This idea helps resolve another long-standing confusion. If matter is mostly empty space, as early atomic models suggested, why does it feel solid? The answer is not that emptiness is somehow filled with invisible barriers. The answer is that fields, when arranged into stable patterns, respond strongly to disturbance. Your hand does not pass through the table because the patterns that define your hand and the patterns that define the table interact in a way that resists overlap. This resistance is not mechanical, it is structural. Seen this way, matter is not a special category separate from light or fields. It is a particular way fields behave when conditions favour rest over travel. Light is motion that moves on, matter is motion that stays. This distinction also helps explain why matter has weight and inertia. Patterns that are settled require effort to change. Once they are moving, they resist being stopped. This resistance is not due to tiny masses clinging to existence. It is due to the field patterns preferring continuity. Nothing about this picture requires us to imagine hidden machinery or sharp boundaries. Everything arises from the same gentle rules we have already encountered. Fields exist. They respond. They allow certain patterns to persist. Atoms, molecules, and materials are simply layers of these patterns, stacked and intertwined, each one resting comfortably within the constraints of the fields beneath them. As we rest with this idea, the world begins to feel both more fluid and more reliable. Solid objects are not fragile illusions, they're robust patterns, patiently maintained. And as we begin to look deeper inside matter itself, we will find that this calm persistence hides an even more dynamic story. One where energy is constantly exchanged, confined, and balanced in ways that give rise to the rich structure of the material world. From the outside, matter appears calm. A stone rests on the ground. A chair waits quietly in a room. A mountain stands unmoving for centuries. After spending time with fields, ripples, and patterns, this calm might seem almost deceptive, and in a sense, it is. Beneath the steady surface of matter lies a world of constant activity, carefully balanced and tightly held. Matter is not quiet because nothing is happening. It is quiet because what is happening is exquisitely contained. To feel this, imagine holding a sealed jar filled with swirling water. From the outside, the jar appears still. It has a clear shape. It sits obediently on a table, but inside the water may be moving endlessly, currents folding over one another, energy circulating without escape. The calm you see is not the absence of motion. It is motion that has nowhere to go. This image brings us gently toward the interior of matter, where some of the most intense activity in the universe takes place. Inside protons and neutrons, the building blocks of atomic nuclei, energy does not drift or spread freely. It is confined. Patterns form, dissolve, and reform in a constant exchange, yet the overall structure remains stable. This stability is not passive. It is maintained through continuous motion, locked into place by the structure of the fields involved. Quarks, the patterns that make up protons and neutrons, are not objects sitting quietly next to one another. They are restless configurations of energy, bound so tightly that separating them becomes impossible in practice. The more one tries to pull them apart, the more energy is drawn into the system, strengthening the bond rather than weakening it. This behavior feels counterintuitive only if we imagine bonds as ropes that stretch until they snap. In the field-based picture, confinement works differently. Pulling on the pattern does not thin it. It excites it. The field responds by pouring more energy into the connection, tightening the hold. A helpful image is that of stretching a rubber sheet with a weight attached beneath it. As you pull outward, the tension does not lessen, it increases. The structure resists separation not by breaking, but by becoming more energetic. This is why the interior of matter can be both violent and stable at the same time. Enormous energies circulate within tiny regions, yet the overall form persists, Protons remain protons, neutrons remain neutrons, atoms hold together across vast spans of time. This restless calm is one of the most important lessons of modern physics. Stability does not come from stillness, it comes from balance. Matter endures because the patterns that compose it are constantly active in ways that cancel out large-scale change. Motion is folded inward, energy is exchanged locally, nothing escapes and nothing collapses. This perspective also reshapes how we think about strength. A strong material is not one whose parts are rigid and unmoving. It is one whose internal patterns are arranged so that disturbances are absorbed and redistributed rather than amplified. When matter breaks, it does not do so because its patterns suddenly vanish. It breaks because the balance among those patterns can no longer be maintained under new conditions. The fields find a different arrangement, one that better fits the altered constraints. This is why matter can change phase, melt, fracture, or transform while remaining governed by the same underlying rules. The fields do not change, the patterns they support do. Inside matter, then, calm is an illusion created by success, the success of patterns that hold together despite constant internal motion. This idea extends naturally to why matter has weight and inertia. When a settled pattern is at rest, changing it requires reorganizing all the motion held within it. That reorganization takes effort. Once the pattern is moving, stopping it again requires the same kind of effort. Weight and inertia are not mysterious properties glued onto objects. They are expressions of how much motion is already being managed inside a stable configuration. This also explains why matter is resilient. Push gently, and the internal patterns adjust and return to balance. Push harder, and they adjust again, perhaps in a new way. Only when the disturbance overwhelms the ability of the fields to redistribute energy does the structure fail. Seen this way, matter is not fragile, it is negotiated. Every solid object is a quiet agreement between fields, energy, and structure, a continuous conversation that has been repeating successfully for a very long time. As we rest with this idea, the solidity of the world begins to feel less like stubborn resistance and more like reliable cooperation. Matter holds together not because it refuses to move, but because it moves in just the right way. This restless calm is not unique to the smaller scales. It echoes upward, in planets, in stars, in galaxies. Motion is constantly balanced by structure. Stability is always active, never inert. By understanding matter as contained motion, we prepare ourselves for a broader view of reality, one where many layers of activity can coexist in the same place, each following its own rules, each largely unaware of the others. This layered stillness will guide us gently forward. For now, it's enough to recognize that beneath every solid surface lies a dance that never stops, held in place by fields that know exactly how to keep it contained. As we become comfortable with the idea that matter is a calm surface hiding restless motion, another quiet realization begins to emerge. The motion inside matter is not governed by a single field alone. Multiple fields coexist in the same region of space, layered together without crowding or collision. This can feel surprising at first, because our everyday intuition struggles with the idea of overlap. In daily life, two solid objects cannot occupy the same place at the same time. One must move aside for the other. Space feels exclusive, as if it must be claimed. But fields do not behave like objects. They do not push one another away. They do not compete for room. They simply coexist, each one describing a different aspect of how space can behave. A helpful way to imagine this is to think about music playing in a room. A melody, a harmony, and a rhythm can all fill the same space at once. They do not block one another. They do not collide. Each follows its own pattern, and together they create something richer than any single line alone. Fields share space in much the same way. At any given point in space, multiple fields are present simultaneously. The electromagnetic field describes how electric and magnetic influences can appear. Other fields describe the behavior of matter itself. Still, others govern how tightly energy can be held together inside particles. None of these fields erase the others. They overlap without interference unless specific interactions are allowed. This layered structure is one of the reasons the universe feels so stable. If fields constantly collided or disrupted one another, reality would be noisy and unpredictable. Instead, each field follows its own quiet rules, responding only when particular conditions bring them into conversation. Most of the time, these conversations do not happen. Fields remain calm, resting in their lowest states, sharing space peacefully. This helps explain why we are aware of only a small fraction of what exists. Our senses are tuned to specific kinds of interactions. We see light because our eyes respond to disturbances in the electromagnetic field. We feel solidity because the fields that define matter resist being rearranged. Other fields pass through us unnoticed, not because they are unreal, but because we have no natural way to sense them. Even the fields we do interact with most often remain largely invisible. We do not see the electromagnetic field itself. We see its effects when it forms ripples we call light. We do not feel the matter fields directly. We feel the resistance that arises when their patterns are disturbed. This selective awareness shapes our picture of reality. We mistake what we can sense for what exists. But the layered nature of fields reminds us that existence is broader than perception. At every moment, space hosts a quiet gathering of possibilities. Fields describing different behaviors overlap, each one ready to respond if energy enters in just the right way. Most of these possibilities remain unrealized, not because they are forbidden, but because nothing has asked them to appear. This idea also softens the sense of isolation we sometimes associate with physical objects. A stone is not cut off from the rest of the universe by sharp boundaries. It is a region where many field patterns have settled into a particular arrangement. Those patterns extend outward, blending seamlessly into the surrounding space. There is no sudden edge where one reality ends and another begins. There are only gradual changes in pattern and intensity. This layered continuity explains why interactions feel local, even though fields are everywhere. When something happens at one place, only the relevant fields respond. The rest remain calm. Information does not spread through every layer at once. It follows the channels defined by the fields involved. This helps preserve order without requiring separation. It also explains why the universe can support extraordinary complexity without becoming tangled. Layers allow different kinds of behavior to coexist without constant interference. Motion in one layer does not automatically disturb motion in another. Consider again the room filled with music. A conversation can take place beneath the music. A heartbeat can continue beneath the conversation. Breathing continues beneath the heartbeat. Each layer operates according to its own rhythm, overlapping but not competing. The universe works the same way. Fields create layers of activity, each one quiet most of the time, each one capable of expression when called upon. As we rest with this picture, the idea of space becomes richer and more spacious at the same time. It is not a crowded container, but a shared stage where many quiet rules coexist, each waiting patiently for its moment. This understanding prepares us gently for a final shift in perspective. If fields can overlap without conflict, and if patterns can extend across space without sharp boundaries, then some patterns may not belong cleanly to a single place. Some ripples may be shared. This thought will guide us toward one of the most intriguing and often misunderstood features of the quantum world. But for now, it is enough to recognize that reality is layered, calm, and generous with space. Many fields can occupy one place, each contributing quietly to the world we experience. After spending time with layers of fields sharing the same space, a calm realization naturally follows. If so many fields exist everywhere, and if they are capable of rich and complex behavior, why does the universe feel so quiet most of the time? The answer is surprisingly simple and deeply soothing. Fields do not seek activity. They do not strive to produce events. Their natural state is rest. Most of the universe is not busy, it is settled. To appreciate this, imagine a vast library late at night. Thousands of books fill the shelves, each one capable of telling a story. But at this moment, none of them are being read. The room is quiet, not because nothing exists there, but because nothing is being activated. The potential is present everywhere, resting patiently. Fields behave in much the same way. They are present at every point in space, carrying enormous potential for motion and interaction. But unless energy enters in a particular way, that potential remains unexpressed. This means that particles are not the default condition of reality. They are exceptions, brief moments when a field is nudged out of rest and allowed to form a recognizable pattern. In everyday thinking, we often reverse this picture. We imagine a universe filled with particles, with empty space squeezed in between. In the field-based view, it is the other way around. Calm fields dominate. Particles appear only where something has disturbed that calm. This explains why the universe can be so vast and yet feel so empty. Between galaxies, between stars, even between atoms, fields remain mostly undisturbed. They do not vanish, they simply rest. This resting state is not fragile, it is remarkably stable. Fields do not decay when left alone, they do not drift toward chaos. Their calmness is not something that must be maintained, it is their natural condition. Only under special circumstances does this calm give way to activity. When energy is concentrated, when conditions align, fields respond. A ripple forms, a pattern appears. For a time, something happens. Then, often, it fades. This rhythm, long periods of quiet punctuated by brief moments of activity, shapes the character of the universe at every scale. Stars burn for billions of years, but even they occupy only tiny regions of space. Galaxies glow, but between them lies a vast stillness. Even within matter itself, most fields are at rest most of the time. The stable patterns that define particles persist, but they do so quietly. Nothing dramatic is occurring from one moment to the next. Stability is maintained not through constant upheaval, but through balance. This quietness also explains why the universe is so predictable. If fields were constantly fluctuating, if patterns were forming and dissolving everywhere at once, consistency would be impossible. Instead, because most of reality is calm, the same patterns can appear again and again under similar conditions. Order thrives in stillness. There is something deeply comforting about this idea. The universe does not rush. It does not vibrate with endless noise. It allows things to happen, but it does not insist on them. Particles, in this view, are like brief thoughts passing through a quiet mind. They appear, linger for a moment, and then dissolve, leaving the underlying calm untouched. This perspective also softens the way we think about emptiness. Empty space is not barren. It is peaceful. It is filled with fields resting in their lowest states, holding the possibility of future motion without demanding it. Silence here is not absence, it is readiness. This understanding reshapes how we interpret the rare events that do occur. A flash of light, a collision of particles, the formation of a star. These are not signs of a chaotic universe. They are localized expressions against a vast, steady background. When something happens, it matters precisely because so much else remains still. This quiet background also makes connection possible. Patterns can travel long distances without interference because there is so little noise to disrupt them. A ripple can cross space cleanly because the field through which it moves is calm. In this sense, silence is not passive, it is enabling. As we rest with this idea, the universe begins to feel less overwhelming. Reality is not a constant barrage of activity. It is a wide field of calm, occasionally punctuated by gentle expressions. This prepares us for a subtle but important shift in perspective. If most of the universe is quiet, and if fields can overlap and extend across space, then some patterns may be shared across regions that appear separate. Some ripples may not belong to a single place at all. We will approach this idea carefully without urgency. For now, it is enough to recognize that stillness is the rule, not the exception. Activity arises within it and then returns to it. The universe rests far more than it moves, and it is within this rest that all motion becomes meaningful. After resting with the idea that the universe is mostly quiet, it becomes possible to approach one of the most misunderstood features of the quantum world without tension. This is the idea that a single pattern can be shared across space, not copied, not divided, simply shared. This idea often arrives wrapped in dramatic language, full of urgency and mystery. But when approached through fields and patterns, it becomes calmer, almost intuitive. To begin, it helps to release one lingering habit of thought, the assumption that every physical thing must belong to one place at a time. That assumption comes naturally from our experience with solid objects. A cup sits on a table, a book rests on a shelf. Each object occupies a single location. But ripples do not behave that way. Imagine a gentle vibration travelling along a stretched rope, held by two people standing far apart. The motion of the rope is not confined to one hand or the other. The pattern exists across the entire length at once. If one person changes how they hold the rope, the pattern everywhere responds. The ripple does not need to send a message from one end to the other. The rope already connects them. Fields provide this same kind of connection, but without a visible thread. When a pattern forms in a field, it can extend across space as a unified whole. The field does not break the pattern into pieces and distribute them. It supports the pattern everywhere it exists. This is the quiet foundation beneath what we call entanglement. Entanglement does not begin with two separate particles sending signals back and forth. It begins with a single pattern that cannot be cleanly separated into independent parts. The pattern belongs to the field, and the field spans space. When such a pattern forms, it is shared by every region it touches. Asking where it is becomes the wrong question. The pattern is not located at a point. It is distributed across the field. This idea can feel strange only if we insist on thinking in terms of objects. Once we think in terms of patterns, it becomes natural. A melody does not belong to one instrument when played by an orchestra. It exists in the coordinated motion of many players at once. Entangled patterns are like that. They are coordinated arrangements of motion across space. This coordination does not require speed. Nothing needs to race from one place to another. The field already provides the structure that allows the pattern to exist as one. When a measurement occurs, it does not force the pattern to choose a location. It reveals how the pattern is expressed at that particular place. The rest of the pattern adjusts accordingly, not because information has been sent, but because the pattern was always one. This distinction is subtle but important. Correlation does not imply communication. When two regions share a pattern, changes in how the pattern appears are linked by structure, not by signals. A helpful everyday analogy is a pair of gloves packed in separate boxes. If you open one box and find a left glove, you instantly know the other box contains the right glove. No message has travelled between the boxes. The information was built into the situation from the start. Entangled patterns work in a similar way, though far more delicately. The field holds a shared structure. Observing one part of it reveals information about the whole. What makes this feel mysterious is that the structure exists across space, not within a single object. But fields are not limited by the boundaries we associate with things. They extend naturally, smoothly, without edges. This also explains why entanglement does not allow messages to be sent faster than light. While correlations appear instantly, usable information does not travel. The pattern is revealed, not transmitted. In the field-based picture, there is nothing to transmit. There is only one pattern being expressed in different places. This understanding replaces drama with quiet clarity. Entanglement is not a loophole in the universe's rules. It is a natural consequence of a reality built from fields rather than objects. When fields support unified patterns, those patterns can span space. When they do, the behaviour we observe follows naturally. This also helps explain why entanglement is fragile. Shared patterns require coherence. Disturb the field too much, introduce too much noise, and the unified pattern dissolves into independent ones. The connection fades not because something breaks, but because the field can no longer support that particular arrangement. Entanglement, then, is not exotic. It is delicate. As we sit with this idea, it becomes less frightening and more elegant. The universe does not enforce separation as strictly as our everyday intuition suggests. It allows unity across distance when conditions permit. Patterns can belong to more than one place, just as a rhythm can be shared by dancers spread across a room. This realization prepares us for one final refinement. If entanglement feels strange only when we imagine particles as objects, then in a world made of fields, it may not be strange at all. We will explore that calm reinterpretation next. For now, it is enough to recognize that some ripples are shared, not split, and that connection can arise from structure rather than speed. Once we step fully into a picture of reality built from fields rather than objects, entanglement begins to lose much of its sharpness. What once felt like a paradox softens into a natural consequence of how fields behave when they support shared patterns. The discomfort surrounding entanglement often comes from trying to fit it into an older framework. If particles are imagined as tiny independent things, each occupying a specific point in space, then entanglement appears to demand something impossible. How could one object instantly affect another far away? How could distance suddenly stop mattering? But fields do not obey the same intuitions as objects. They are not collections of separate pieces. They are continuous structures, capable of holding patterns that stretch smoothly across space. In a field-based world, unity is not the exception. Separation is. When a field supports a pattern, that pattern belongs to the field as a whole. It does not need to be divided into local fragments that must coordinate later. The coordination already exists. The field provides it from the beginning. This is why entanglement feels strange only when we insist on asking object-based questions. Questions like, which particle changed first? Or, how did the information travel? Assume that there are separate things that must exchange messages. In a shared field pattern, those assumptions no longer apply. A gentler way to think about measurement helps here. Measurement is often described as an action, something done forcefully to a system. But in a field-based view, measurement is closer to a question than a command. It is an interaction that asks how a pattern is expressed at a particular location. When the field responds, it does not reorganize itself violently. It reveals a consistent aspect of a pattern that was already there. The rest of the field adjusts not because it has been instructed to do so, but because the pattern remains unified. This is why entanglement does not involve signals racing across space. Nothing needs to catch up. The field already holds the answer. A useful everyday analogy is a perfectly synchronized pair of clocks set in advance. If you glance at one clock and see the time, you instantly know what the other clock shows. No signal has travelled between them at that moment. Their agreement was built in from the start. Entangled patterns are not identical to clocks, but the analogy captures the calmness of the situation. Correlation does not require communication. It requires structure. This structural view also explains why entanglement does not violate the universe's speed limits. While correlations appear immediately, they cannot be used to send messages or control outcomes at a distance. The field reveals information consistently, but it does not offer a way to manipulate one region independently of the whole. The universe preserves causality not by forbidding shared patterns, but by limiting how those patterns can be used. Another source of confusion comes from imagining measurement as collapsing something that was previously vague. In the field-based picture, collapse is not a violent snap. It is a transition from a shared pattern to a more localized one. The field settles into a configuration that fits the new constraints introduced by interaction. Nothing is destroyed, nothing is forced. A pattern simply changes form. This also helps explain why entanglement is sensitive to disturbance. Shared patterns require coherence across space. Noise, interactions, and environmental influence introduce competing patterns. When these overwhelm the original structure, the shared pattern dissolves naturally into separate ones. Entanglement fades not because it is fragile in a mysterious way, but because maintaining unity across space requires careful balance. Seen this way, entanglement is not a strange add-on to physics. It is what we should expect in a universe where fields are fundamental and patterns can extend freely. The surprise lies not in entanglement itself, but in how long we try to describe reality using only the language of objects. Once we allow fields to take center stage, many of the sharp edges soften. Distance becomes less absolute. Location becomes a property of expression rather than ownership. Connection arises from structure rather than from exchange. This does not make the universe less precise. It makes it more coherent. Entanglement in this light is not a breach of order. It is a reflection of a deeper order that operates quietly beneath the surface of everyday experience. A reminder that separation is not always as complete as it appears. As we approach the final stage of our journey, this understanding allows us to gather all the threads we have followed. Fields, ripples, stability, silence, and shared patterns are not separate ideas. They are aspects of a single patient picture. Reality is not assembled from rigid pieces. It unfolds from continuous structures, shaped by allowed motion and gentle constraint. With this perspective in place, we are ready to rest with a unified view, one that does not rush to explain every detail, but instead offers a calm sense of coherence beneath complexity. In the end, the universe may be less like a machine made of parts, and more like a symphony made of overlapping themes, each one clear on its own, all of them sharing the same space, guided by the same quiet rules. As our journey slows toward its end, it becomes possible to step back and take in the whole picture at once without strain or urgency. What once appeared as a collection of strange rules and puzzling behaviours now settles into something quieter, more coherent, and more humanly graspable. The universe, seen through this lens, is not built from tiny stubborn pieces of matter. It is shaped by fields that fill all of space, patient and continuous, always present whether anything seems to be happening or not. These fields are not decorations laid on top of empty space. They are the stage itself, the conditions that make motion, energy, and structure possible. Within these fields, most of reality rests. Calm is the default. Silence is not emptiness, but balance. The universe does not constantly vibrate with activity. It waits. And when something does happen, it happens gently, according to what the fields allow. Particles, which once seemed like the fundamental building blocks of everything, now appear in a softer role. They are not bricks from which the world is assembled. They are notes played by the fields, stable vibrations that arise, persist for a time, and then fade back into stillness. A photon is a travelling rhythm in the electromagnetic field. An electron is a settled pattern, held in place by the surrounding structure. Quarks are intense, confined storms of motion, balanced so precisely that they endure. None of these are things in the everyday sense. They are actions the universe knows how to repeat. This shift in perspective changes how we understand change itself. Change does not happen continuously in every imaginable way. It happens in allowed steps, like a melody that moves from one note to the next. The universe evolves through patterns that fit its structure. Between those patterns, nothing can remain. This is why the quantum world feels both smooth and discrete. Smooth, because fields are continuous everywhere. Discrete, because only certain vibrations can persist. There is no contradiction here. Discreteness is not imposed on smoothness. It emerges from it. When we view reality this way, many long-standing puzzles soften. The wave-like and particle-like behaviours of light no longer clash. Entanglement no longer feels like a violation of distance. Measurement no longer feels like an act of force. Each becomes a natural expression of how fields support and reveal patterns. Even solidity, the most familiar feature of our everyday world, finds a new explanation. Objects feel solid not because they are made of hard pieces, but because the patterns that compose them resist being rearranged. Solidity is not stillness. It is organized motion, held in place by balance. At the same time, this picture invites a sense of humility. We experience only a narrow slice of what exists. Our senses are tuned to a few kinds of field interactions, a few rhythms among countless possibilities. Most of reality passes through us unnoticed, not because it is hidden, but because it is quiet. There are layers upon layers of existence sharing the same space, each one calm and less disturbed, each one following its own gentle rules. The world we know emerges where these layers happen to meet in ways our bodies can register. This layered calm also brings a sense of unity. Nothing in the universe is truly isolated. Fields extend everywhere. Patterns blend smoothly into one another. Boundaries are not walls, but regions where behavior changes gradually. Even separation itself becomes a matter of perspective. Patterns can be local or shared. Some belong clearly to one place. Others stretch across space as unified wholes. Connection does not require signals rushing through emptiness. It arises naturally from shared structure. Seen this way, the universe feels less like a collection of isolated parts and more like a single, vast composition. Themes repeat, variations appear, quiet passages dominate, punctuated by moments of intensity. Everything follows from the same underlying principles patiently applied. There is no hurry in this picture, no need for constant activity. The universe has time. This calm does not make reality less rich, it makes it more trustworthy. Patterns repeat because they are allowed to. Structures endure because they are balanced. Change happens because conditions invite it, not because chaos demands it. As you rest with this final image, it may be helpful to let go of the need to remember details or definitions. What matters is the feeling of coherence beneath complexity, the sense that the world at its deepest level is not hostile or arbitrary, but orderly in a quiet, almost musical way. Reality unfolds one allowed step at a time. Fields hum softly beneath everything. Most of existence remains at rest. And from that rest all motion gains meaning. And so we come to stillness. Whether your thoughts remain with these ideas or drift elsewhere now, the universe continues its patient rhythm. Fields remain. Patterns rise and fade. Silence holds it all together. You do not need to hold on to the symphony. It is already playing, softly, everywhere.